Hey there! In this video, I'll share with you an effective method for explaining the trends of the elements in groups 2 and 1 of the periodic table. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Let's launch our solution to the question from a very basic concept, atomic structure. In particular, the electron configuration of these elements, how the electrons are arranged on the shells surrounding the nucleus. Beryllium is element number 4. So, using the principle, the first shell can hold a maximum of 2 electrons, and we'll use 8 for the second shell, 8 for the third shell, and so on. We can write the electron configuration for beryllium as 2, 2. Magnesium being element number 12, or element with atomic number 12, will have the electron configuration 2, so the first shell is full. The second shell can hold a maximum of 8 electrons. That's also full now. So the remaining 2 electrons will go on the third shell. Then we have calcium with atomic number 20. And the electron configuration will be 2, 8, 8, 2. We are noticing already a trend with the alkaline earth metals, the group 2 elements. And that trend is, as we go down the group from top to bottom, the valence electrons are the same in terms of amount. So all the group 2 elements have 2 electrons in their very last shell, or their valence shell. And by the way, this works the same way for the group 1 elements, the main group 3, 4, 5, 6, and 7 elements, right? So the number of valence electrons will tell us the group number for that element. There's also another trend that we are recognizing, and that is, as we go down the group from top to bottom, we are adding a new full inner shell. But let's draw a simple model to represent the electron configuration of these elements to make things even clearer. So beryllium with atomic number 4 can be drawn as such: the first shell and the second shell with simple circles. Magnesium has 3 shells: 1, 2, 3. And calcium has 1, 2, 3, 4 shells. First shell, second shell, third shell, and the fourth shell. Let's now put on the electrons using dots. So beryllium has 2 electrons on the first shell and 2 on the second. I'll put the electrons on the second shell apart, just like this. For magnesium, we'll have 2 on the first shell, then a total of 8 will go around one by one first, and then in pairs, and then 2 on the very last shell, the valence shell. Calcium has 2 electrons on the first shell, 8 electrons on the second shell, 8 electrons on the third shell, and 2 electrons on the fourth shell. Another trend that we are picking up here is that the amount of shells will give us the period number. So magnesium is in period 3. And now let's dive in a little deeper. The nucleus of these atoms, and let's just imagine that it's there in our diagrams. The nucleus of these atoms contain protons which are positively charged, and they are attracting the electrons. Our concern is with the valence electrons. Now, for beryllium, the attractive pull between the nucleus and the valence electrons is stronger than the attractive pull between the nucleus for magnesium and its valence electrons. And that is because there are more electrons between the nucleus and the valence shell for magnesium than there are in beryllium. And that is described as shielding effect. So as we go down the group, shielding effect increases because there is an addition of a new full inner shell with each successive element. That has a number of effects. The first effect is that atomic radius increases as we go down the group, and this increase in atomic radius is due to the increase in shielding effect because the attraction between the positively charged protons in the nucleus and the negatively charged valence electrons gets weaker as we go down the group. Another effect this has is that these elements lower in the group will have a greater reactivity. So these elements react far greater with much more vigor than the element at the top of the group. And that is because when metals react, they do so by losing their electrons to become cations. So if the electrons are more easily lost from the atom in the formation of ions, then the atom itself will be more reactive. And we can see this with how magnesium and calcium reacts with cold water. So with cold water, magnesium reacts very slowly, as opposed to calcium, which reacts very vigorously with cold water. The ease of ionization, how easy these elements can become ions, increases down the group. Also, this causes the melting point of the elements to decrease going down the group. And that is because the attraction between the nucleus of these atoms and their valence electrons gets weaker with each successive element. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to refer to the concept of shielding effect and the attractive pull between the nucleus of an atom and the valence electrons to explain the increase in atomic radius, ease of ionization and reactivity, and the decrease in melting point going down groups 2 and 1 of the periodic table. Good luck on your exams, and I'll see you next time.